on ratios, rates, and conversions. So we have to go through a couple vocab terms first. So the first thing here is a ratio. A ratio is just a comparison of numbers. All right, ratios can be written in many different forms. The most common for this class would be in fraction form. So comparing 3 and 5 is 3/5. You could also write them as 3 to 5, or you could write it using a colon. Right, the next thing is a rate. A rate is just a ratio with labels. Okay, so that would be, if we would say, use our ratio 3/5, we could write 3 miles per 5 hours. That would be a rate. With a rate, we are comparing two different units. For my example, I compared miles to hours, which would be my two units that make up my rate. We also have unit rates, which unit rates is just a rate with a denominator of 1, which would be the most common type of rates that you guys will see in the real world. So when we drive, we usually say miles per 1 hour. So if I'm on a highway, I might be driving 50 miles in 1 hour. That would be considered a unit rate. So when we write ratios, commonly we are comparing a couple different things. We could be comparing lengths. Oops, I just forgot the E completely. Different measurements. Different times, etc. A couple of common examples would be miles per hour or money over quantity, which would be like dollars per item or maybe dollars per hour. Okay, these are kind of our common types of rates and ratios. So in the next example here, we are going to be comparing unit rates. So let's read the word problem. Actually, wait, no, comparing unit rates, let's leave this one for class and do it together. If you guys want to give it a try on your own, go for it, but I think this would be best done in class. Okay, the next vocab term here is a conversion factor. So conversion factors are a ratio of two equivalent measures in different units. So what those rates would look like is if we have 1 foot over blank inches, how many inches is equivalent to 1 foot? Well, lots of you know that 12 inches is 1 foot. So that would be considered a conversion factor because both 1 foot and 12 inches are equivalent measurements. If we have 5,280 feet, that is equivalent to 1 mile. 1 meter is equivalent to 100 centimeters. 1 hour is equivalent to 60 minutes. And 1 minute is equivalent to 60 seconds. This one's a little more difficult. If we have 3,600 seconds, that is actually 1 hour time. So make sure you guys write all of these different conversion factors down. Although in most problems, I will give you your unit conversions. These are some of the most common ones that we'll see throughout the unit. So let's go over an example of how we're actually going to see this. So in this first example here, we have 1 foot and 3 inches converted to inches. So the first thing we need to ask ourselves is the first thing we need to do is we need to convert our feet into inches. Then we'll add our 3 inches to that amount. So right now, we have 1 foot. 1 foot is how many inches? Well, most of you know that is 12 inches. So my 1 foot is going to turn into 12 inches. Then I need to add my additional 3 inches to that amount, which is going to give me a total of 15 inches, which is my answer for that problem. So obviously that example is a fairly, simple unit conversion, but sometimes it won't be that easy. Like in example 2 here, we have 1,250 centimeters converted to meters. So how I want you to set this up is take your initial value, which is 1,250 centimeters, and put that value over 1. So that will be my first fraction. 1,250 centimeters all over 1. Now I'm going to use my conversion factors that we went over on the last page to convert my units of centimeters into meters. Well, looking at your unit conversions, my unit conversion that involves both centimeters and meters is 100 centimeters equals 1 meter. So now we'll use our fraction that we looked at in the back side to convert this. How I'll do this is I'm going to put 100 centimeters in my denominator and 1 meter in my numerator. The reason I set it up this way is so that my units that I no longer want will cancel out diagonally, leave me with just meters. Once you get to this step, this is just fraction multiplication. So 1,250 times 1 is just 1,250. 1 times 100 is just 100. At this step, make sure that we write down our units, which now is going to be meters. For all of these problems, we're going to want to calculate these out all the way. So let's actually do our division here. 1,250 divided by 100 is just going to leave me with 125 meters. Actually, 12.5 meters. Okay. Our last example here, you guys can do that one on your own. Let's look at our converting between systems. So I'm going to do the first one. We'll leave the second one for together in class. So the first one here, the Sears Tower in Chicago, Illinois is 1,450 feet tall. How many meters tall is the tower? As you can see here, they are giving us our unit conversions to go from meters to feet. So first of all, let's go ahead and list our initial value. We've got 1,450 feet, and our initial value, we'll just put that over 1. Now we're going to use our unit conversion to convert our feet to meters. Like I said below, whatever value you want to cancel out, you need to put diagonally. So we are going to put 3.28 feet in our denominator, and we'll put 1 meter in our numerator. That way, our unit of feet are going to cancel out. Just like the last problem, let's do fraction multiplication. So 1,450 times 1 which is just 1,450, over 1 times 3.28, which is just 3.28. Make sure we write our meters with our answer here. Now, you guys can use a calculator to divide these out. 1,450 divided by 3.28, which is going to give us an answer of 442 point, I'm going to round up here, 1 meters. All right, I want you guys to try this example with the athlete on your own, but we'll make sure to go over it together in class. All right, please bring any questions you have to class, and thanks for watching.